I'm here today on, well, no, I'm not here today just because I'm on behalf of Albert Mission. I actually did organize a small conference. I don't know if you heard about it. But I'm here to represent Albert Mission, which is a French explorer, and I need to find his presentation. That always helps. There you go. I met Albert Mission when I was actually preparing BIODYSSEUS. So Albert Mission is actually a French explorer. He stopped going to school at the age of 15, and he decided to create his own school for diving. And he got crazy about ice diving, created his own ice diving school, went on explorations. He spent, I think his first exploration, there were 8 people, then there were 2 people doing canoe in Greenland for, I think, about 45 days. And then he actually was in North Pole for like 54 days on his own. He actually froze his eyeballs. And yeah, you have to find a way to, because basically the wind was just coming straight at his eyes and then he couldn't see anything. And he managed to, get out of this and get out of there alive. And he actually did the extreme environment trainings for BIODYSSEUS, has been doing that for about 4 years. And he's very interested in space, and mainly sustainability. So he's been diving under the ice for many, many years, and he's seen how much climate change is actually impacting the fauna and the flora. And you can see this in the Arctic and Antarctica much quicker than you can see it actually in our countries. Although Switzerland, you do see it much quicker. So I'm here to represent Station BIODYSSEUS, Mission BIODYSSEUS. Just a few facts about exploration and underwater habitat, because we're not talking just sustainability, we're talking habitat under the ice for sustainability research and space research. So it's a bit in crossroads of the both. And if you look at it a bit from history, so there were already some underwater habitats such as Précontinent 1, Précontinent 2, Précontinent 3, Janus 4, Comex, and Hydra X. So first there was like about minus 10 meters for about a week, then it was about a month between minus 10 and 16 meters, and then it was in 1977, minus 500 meters below the sea, and then minus 700 meters in a pressurized vessel. So it's not really new to have habitats underwater, but obviously it's new to think just space. Obviously you have the NEMO missions, you have hydronauts, you do have analog missions with these, but usually you think more, okay, saturation diving, you think Mariana Trench, etc. So it's not always associated with space, except for the few, and even Hydronaut is actually quite old. We're actually organizing a workshop there, and NEMO is not really in operation that much. So, there's not much going on. And also, these are actually in warmer waters, or temperated waters, and they're not in effing freezing water, if I could say. Obviously, hot mic. So, a few facts about it. BIODYSSEUS was created to answer to find an answer to some problems. So obviously, we want to participate in the training of personnel in extreme environments for space, but also for sustainability and for exploration. It was also to supervise and simulate EVAs. I mean, the biggest problems that we have with analogs is that we have those spacesuits that just fog up and they're just so warm, but it's mainly because we have to carry them. I mean, in space, okay, your spacesuit might be 200 kilos, so we estimate 50 kilos on Earth, but actually, on the long run, they might be much lighter, and you won't have to, carry that much, or hopefully a bit less. And the main thing that astronauts describe when they're doing the training in neutral buoyancy lab is that it's difficult to actually handle things because you're floating. So microgravity seems to be the one thing that you really need to train in how you float, how it's reacting. So doing the training on the water is a very interesting one. Doing the training on the ice means you really have to be careful about the temperature, which is also a problem in space. Obviously, when you're exposed to sun, it's fine, but when you're not, you're actually bloody freezing. So developing the portable life support system that goes with it actually makes sense. And then we want to do, obviously, testing, innovating and improving technologies and harsh environments. Sorry for the bad translation. I had the not a lot of time. And also by answering the lack of funds from the state. So Albert Michon is not a billionaire, not a millionaire at all. We're looking for money. But the goal is to really find a way to motivate anyone to come there and to find a solution. It's not a billionaire's idea. The goal is not to build a golden habitat under the ice and it's crazy and we're just going, no, it's actually a very, very interesting and reasonable project. So a few facts, basically the budgets for infrastructure and logistics in general for countries that operate stations in the Arctic and the water. So, for example, you have about 18 million and 14 million in investments for France, 53 for Germany, to 1,000 for recent investments. So these are some of the numbers. So you see that the countries that are very involved in it are France. So Albert Michon is French, so the way to go about it is through France, so that's why you've got those numbers. But you can see that these are the countries that are mostly interested in it. Germany is actually quite high, and Great Britain. And Australia somehow is very, very high. And it's quite a disruptive station, so that's actually Alban coming out of a simulated airlock. And what is really interesting about the station is it's not going to be necessarily fixed. The goal is that you actually build it in the next years. So in January 2025, we're going to first test an under ice, so sub-ice tent, where we want to put system, we want to put people for about 2 days and see how they survive. And then we want to create this habitat that will be modulable. So you'd have different modules that you can actually transport instead of saying, okay, I'm building a 200 square meter concrete thing under the ice. No, okay, you do something that's modulable, that's transportable, and you start first with some tests in Tignes, which is in France, which is in a ski resort where the lake always freezes. You do a small test there, and then you move to Greenland, and then you move up all the way to the Arctic. The goal would be that it's accessible to most. It would be actually pressurized, but not completely. It would be like atmospheric pressure, and then you would have an airlock, and you would be at low depth. So the goal is not to go to 200 meters. In the end, as soon as you're below the water and you're in a spacesuit or you're in your diving suit, you're already simulating microgravity. It doesn't change if you're like 100 meters. It just means you've got more decompression steps that you have to do, more time, more dangerous. Honestly, it's dangerous enough that you're under the water, under the ice, and far away from every people on Earth. So honestly, it's fine. Like, you don't need to go much more. But you put it by about -4, -6 meters. And then you can add different modules. So you do sort of plug and play kind of thing. And the goal is that the station lasts for 20 years. It's not a thing that should be there for like 1 or 2 years. It's actually for 20 years. Water temperature, where we want to first go in Greenland would be 1.6 degrees Celsius. You'd have up to 4 people at a time. You'd have a submarine robot with an umbilical and maybe some vehicles that could be tested. 3 laboratories. You'd have 1 in the station, 1 on the surface, and 1 underwater outside of the lab. And you have a surface base, something that we call in French base arrière, which is basically this base that looks after you. And I'm going to talk about this in a second. And then you have a sort of meeting bubble below the water, safety, recording studio if you want some really cool pictures of fire, and that's just for you, for the photos, obviously. But obviously, it's still very much a big dream. We'll see how much of it is feasible. But we actually already looked at the design of the modules, how we would be doing it, and a lot of this will be feasible. You have a surface rear base for emergencies. Indeed, it's nice to have an underwater station, but as I said, you're already in enough danger as it is, so it's good to have one above the water that is basically your MCC. So actually, for mission simulation, it would be increasing the level of fidelity because you're not completely on your own. You do have someone that's there to take care of you. And what we would do with all of this is do a study of ice caps changes, a study of the northern lights, meteorological measurements. It's good to always get more data on this, atmospheric pollution, wildlife. So this is more like Earth sort of based, but also like things like the permafrost, human and social sciences. Obviously, again, 4 people in a box, a very freezing box, very interesting. And the material testing environment is very interesting. Myself, I'm a material scientist, and one of the things I was actually really excited about maybe going to the Arctic and going to the Arctic there and going to Antarctica in 2 years is the material science. And when you put the material and you cycle it between temperatures, that's where you get the most interesting results. That's where you get a material that goes from being brittle to ductile, or opposite. And then suddenly the behavior is completely different. And then you're like, actually, it doesn't work. Haha. So this is really, really good because it's the perfect library to test this. And then you can do really a wide array of experiments. And it's a completely new and imaginative R&D station because it's under the ice, it's on the water and under the ice, and you can do sustainability studies, and you can do space studies. So it's really all connected together. This is like not AI generated, but sort of CAD design. So it's in French because I don't have the modifiable original. This is the control center. This would be the underwater hangars. This would be the laboratory. This would be like numerical windows, so you can't actually see through them. They just display what's happening outside, so that you have sort of a feel that you can see things. And then you would have instruments, scientific instruments for measurements, and then here you would have not wind turbine, a turbine, a water turbine, so that you can actually generate some electricity from the current. Again, this is the more conceptual part of it, and these are some other images of how it would look like. So you would see here, you would have a diver that would come out of the airlock, and you would be able to see what's going on. You would have a pressure suit. It would be about 28 meters long, at a depth between 5 and 20 meters, I said, and you would have 4 interconnected modules to get started at about 7 meters long, and all of them are atmospheric pressure. And you would have a robotic arm at the end. I think it's the next slide where you can see. No, don't have more details. But you have the sleeping quarters in it. You have the scientific experiments. You obviously have the living module, and you have also anything for maintenance. What's very interesting, something that we've been looking at with Alban, is a way to actually generate oxygen in it. So he's been working with Lucie Poulet, and she's been looking at the algae used for oxygen generation. Usually you don't manage to generate a lot of oxygen, but we're still looking into that. And I'm not going to talk for much longer, because obviously I'm slightly part of the project, but we're still at the beginning of it. We looked at really this kind of circular module. We have a company in the US that manufactures it in composites. Everybody who's been looking at the Titan accident last year is looking forward to this, but hopefully this time we do it right. So we'll have to find a way to have this great whole structure, and that you can, modulate and attach together. And a bit about the equipment in the laboratory. You have scientific instruments inside and out, as mentioned, to do current analysis, hydrophone, salinity measurements, pH measurements. These are very important, for example, climate change measurements. You have also inventory of submarine fauna and flora, a human impact analysis, clinical study with live monitoring of the crew, understanding of how the species might adapt to environment, and also research on photosynthesis during polar nights, which is also a very interesting field of study. And the goal would be to have also recycling of air and water. It was a use of a 3D printer, but also for biomaterials, use of energy, and have a way to insulate yourself from the heat, because obviously that's going to be the biggest problem. How do we stay warm? And then use of farming to create mushrooms and salad, and do studies with this photobioreactor for the oxygen generation, by bacteria. And a little bit about roadmap. So we want to do BIODYSSEUS expedition, BIODYSSEUS lab, BIODYSSEUS station. 2024 is R&D, then it's test and funding. This is where we get started with first the tent, do a small expedition in 2026, obviously promotion. So obviously it's the same way as when you prepare for an expedition or Analogue mission, a lot of it goes into the expedition preparation and getting the funds. Then we hope that in 2026 we do fundraising and construction, 2027 laboratory installation, and then 2028 operation promotion, etc. And then the full station would be 2029, we hope, 2030. Alban Michon told me that he wants to be in there for 6 months. So 4 people, he wants to be there 6 months. Really, he wants to see how can we survive in this. And he really wants to invite Thomas Pesquet, because he's a good French, and we all like Thomas Pesquet. So let's try and support him in this. Obviously, it's still at the beginning. Alban is obviously very happy to communicate with new people. He doesn't speak English very well, so I'm his interpreter, actually. So, but if you're interested, then you can reach out. Alban is right now in expedition in the Arctic again, so that's why he couldn't come today. But it would be really great if you find any interest, then you can come to me. We're going to switch to LeJect right away, but if you're interested in learning more, either you come to me or you write to Alban, because I don't have a huge amount of information for some details, so more technical details, it's better if you directly address them to Alban. Okay.